Before I give you the next exercise, I need you to accept that the limit of this thing as n heads towards infinity will be 0 for a and b, for a and b being greater than 0. So I need you to accept that the limit of this thing as n heads towards infinity equals 0. So let's try and understand why that's the case. If we put, let's say, 3 into the a and let's put 2 into the b. So for example, let's look at this case here where a is 3, b is 2. Let's try and understand why the limit of this equals 0. Well, if you have a quick glance at this, understand that natural log climbs very, very slow. And then you've got x squared. X squared is, well, it climbs very, very fast in comparison to the natural log. So let's try and understand why the limit of this equals 0. So as n heads towards infinity, this thing here will head towards infinity. The denominator will head towards infinity. You've got infinity over infinity, which is an indeterminate form, which means you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate the top, that will then give you this. Differentiate the bottom, that will then give you this. So now tidy this up. If you tidy this up, it will become this. So now notice that this is still in the form of n squared, but then this thing here, 3, it goes down by 1. So just bear that in mind. Now let's check it again. As n heads towards infinity, this thing here will be infinity, this thing here will be infinity. It's an indeterminate form, so we can apply L'Hopital's rule again. So applying L'Hopital's rule, differentiate the top, that will then give you this, and then differentiate the bottom, that will then give you this. And notice that every time you differentiate this, you've got this 1 over n. Well, if you tidy this up, this n here will come down to the bottom. So giving you this. So notice that every time you apply L'Hopital's rule, this power here goes down by 1. So here you've got 1, and then this here stays the same. It's because when you differentiate this, you've got this 1 over n thing, and then this 1 over n just compounds to this thing here. So every time you apply L'Hopital's rule, this thing here, the denominator in a way stays the same, but then this power here gets minus by 1 at the top. Well, anyway, that will then take you to here. Now, as n heads towards infinity, this thing here will be infinity, this thing here will be infinity. Apply L'Hopital's rule again. So applying L'Hopital's rule again, differentiate the top, that will then give you this. Differentiate the bottom, that will then give you this. Tidy this up, and it will then give you this. So now as n heads towards infinity, this is a constant. This is just going to get bigger and bigger and bigger. So the limit will be 0. So if you have this 3 and 2, the limit is actually 0. Let's look at another example. Let's just have a look at another example. So now let's look at a case where this a here is a 2 and this b here is a really small number, 0.01. So now apply. So this here is infinity over infinity. So we can apply L'Hopital's rule. So differentiate this. That will then give us this. Now differentiate the bottom. That will then give us this thing here. So when you differentiate this goes down 0.01, and then the power gets minus by 1. So that will then give you this thing here. Okay, so now tidy this thing up. So you've got this thing here, and then you've got your n to the power of minus 0.99, which is this bit here. But then this thing here goes to the n here goes to the bottom, giving you this n here. Well, now merge these two together. So that will then give you. So imagine this as being a 1 here. So 1 plus this thing here, that will then give you 0.01, back to where you started. So now so that will then take you to here, and then check it. As n heads towards infinity, this thing here is going to be infinity, this thing here is going to be infinity. You've got infinity over infinity, which means you can apply L'Hopital's rule. So applying L'Hopital's rule, differentiate the top, that will then give you this. Differentiate the bottom again, that's going to take you back to this minus 0.99 thing again. But if you tidy it up again, this negative 0.99 thing here becomes this if you tidy it up again. Well, anyway, tidy this up. That will then give you this. So now as n heads towards infinity, this thing here, well, if you look at the graph, square root of x looks like this. Square root of, let's say, n to the power of, let's say, I don't know, hang on. Well, this thing here, as it gets smaller and smaller, it will be like this, but it still keeps on climbing. This thing here will keep on climbing. This thing here eventually will head towards infinity. So the limit of this thing here will be 0. So the moral of the story here is that if the limit of this thing here as n heads to infinity, it will be 0. Okay, so even if you have, I don't know, natural log of 98 to the over, let's say, n to the power of 32, the limit of this will be 0 as n heads towards infinity. Okay, so accept that the limit of this as n heads towards infinity equals 0. Okay.